off. Nathan, were you gonna?
I was trying to transfer it to over meters to seconds, or over meters and seconds.
Do you want me to change the miles to meters? Yeah, what, traveling 10, I was trying to pick realistic numbers that we could do in our head. All right,
So you said it's change of velocity. How are we supposed to know what is the change?
I'm not asking for a change in velocity, I'm asking for average velocity. It's just the displacement divided by the time.
Yeah, I'm trying to figure out the top number, the displacement.
Okay, so what is the displacement in my nice little simple scenario?
200 miles.
Okay.
So close,
200 miles.
so close.
Miles per hour?
There we go, direction matters, north. So this is 200 miles north. And I'll just do N for north.
Over 10 hours.
Yep.
Okay.
And so what we end up with is 20 miles per hour. As was stated, you left direction off, north. That's my average velocity.
And that's how we calculate it every time. We put the displacement at the top, the time at the bottom.
Yep,
Okay.
if you're finding average velocity. We'll eventually get a different way of finding average velocity also, but.
Question.
Yeah, Brianna.
The subscript on the velocities, is that an AV?
Yes,
Okay.
for average.
Okay, perfect.
What's the difference between how you have that, there's a line on top of it, and the one to the right, there's no line? That one, 600 over 10, and to the left,
The fact that I have a line there,
no, up there. To the left, the velocity average, the difference between that one and the one that has a line over it, to the far left, yeah.
that's indicating, it's slightly more than a line, it's an arrow. That's telling us that we're dealing with a vector.
Oh, okay.
This is telling us that this is velocity, and because I don't have it, this is speed.
Oh, okay.
The symbol for speed is just final speed.
The 10 hours for the let's go velocity. Are you? I guess it just makes sense that it takes 10 hours to go up north. I don't. Maybe I'm just thinking about it too much. But why it takes 10 hours to do 600 miles, but it also takes 10 hours to do 200 miles.
The 200 miles is just where we are relative to where we started. It's not saying we actually went 200 miles. The distance traveled was 600 miles.
Okay.
The 200 miles is just where am I relative to my starting point.
Okay. I see.
So, displacement is more along the lines of as the crow flies.
So
Right?
velocity is how fast an object goes, but it's not the same as speed.
Because velocity is how fast an object goes and in what direction. That's the key difference right there. Speed is just how fast you're going,
Why does direction matter?
because it's a vector.
Okay.
Because it's gonna tell us information that if we end up with a velocity that's negative, that means it's going in the negative direction. If we get a velocity that's positive, it means it's going in the positive direction. It's a little bit of more information than just speed. If I saw a speeding ticket that, I'm gonna guess someone in here has gotten a speeding ticket, I hope not, but let's just assume someone in here has gotten a speeding ticket. And I'm looking at it, I am gonna have no idea which direction they're going in, because all they ticket you for is speeding, they don't ticket you for velocity-ing. And potentially you were there when that word was created. I don't think they ever tell direction, they might, location, they might say, give you a position, but you don't get a ticket for going, you don't get a speeding ticket because of the direction you're going.
So how does your direction change your speed? Like if you're going 60 miles an hour, how does it matter if you're going backwards or forward? Shouldn't you still be going 60 miles an hour? Like your speed is your speed, right? How fast you're going is just how fast you're going. No matter what direction you're going.
Alright, let me do the Usain Bolt bit,
Okay.
and then ask your question again.
Okay.
I'm hoping that'll clear it up.
Okay.
Alright, so I made the claim earlier, I'm as fast as Usain Bolt, or even faster, and let's talk about how that can possibly be. I do need room. Put speed back. Alright, so I'm gonna race. Got a starting point right here, we're gonna go around the track once. So, me and Usain Bolt. The gun fires, they go racing around. Usain Bolt goes all the way around the track in 40 seconds. I go around the track in, we'll just say 3 minutes. I'm feeling good that day. Let's look at average velocity. What is Usain Bolt's average velocity?
About 40 seconds?
He did it in 40 seconds, around the track. The track is, what, about 400 meters?
Yeah, 400 meters.
Alright, so it goes around 400 meters in 40 seconds. What is his average velocity?
400 over
We don't know the
40.
direction to go.
How do you want to define that?
Well, I don't know, cause I mean, it's just a circle, so I wanna know if it's north, south, or.
He went to the left, right?
Starting point was here, the end point was here. Basically around the track once.
So 400 over 40.
Ooh.
No?
If I was asking for average speed, yes, absolutely. But I'm not asking for speed.
Wait, is it 0?
Yes,
Oh.
It seems
and don't forget
wrong.
units. But why is it 0?
Because it's starting and ending at the same spot.
Yeah, after 40 seconds, Usain Bolt hadn't gone anywhere.
Okay.
After 3 minutes, I hadn't gone anywhere. So our average velocities are the same in this race. Now let's take it one step further. I'm faster than Usain Bolt. When he finishes, I'm somewhere around here. After 40 seconds, he's gone nowhere, but I've gone somewhere. I'm faster than Usain Bolt. So this is a speed versus velocity thing. Now, how does it, let me throw in one other bit of how does that make any sense. Think back to how you average things. You average numbers by adding them up and dividing by however many you got. I'm getting general nods. I'm assuming that's common knowledge, but I did have a class a couple years ago where someone did ask, how do you average numbers? So just a quick. The average number, I add them up, I get 10, and then I divide by however many numbers I have. So the average number is 2.5. Now, when I'm dealing with average velocity, I add up my velocities, and I divide by however many I got. Well, I got a velocity, let me clean up the track a little bit there. I have a velocity, I start out going this way, and then this way, and then this way, and then this way. I'm gonna also shorten the track. So if I just snapshot of my velocities all along the path, I have basically a whole bunch of little arrows pointing like that. Flash back to adding vectors. Head to tail. For every vector I have going that way, I have one going in the opposite direction. Those two would add up to 0. That and that add up to 0. I'm just adding up a whole bunch of numbers here that basically end up back where I started. So that's also how average velocity ends up being 0 when you end up back where you started. All right. Questions on this before I get back to what Lay's question was a moment ago? All right, Lay, do you still have the question, and what was it again?
I think I understand because it's about the change in position velocity has more to do with displacement than speed. So I guess I understand.
All right. Now I do have to introduce, before we get to acceleration, which we'll do last, acceleration is the most complicated one. I do need to introduce, just like split in the vocabulary. There are two different kinds of displacement. One is instantaneous, and let's see if I can find it. Decent. That is not. What's purple doing today? Ah, there. Instantaneous. And overall. Because as I'm going around the track here, my overall displacement, which is what I was asking about here, my overall displacement is where am I relative to where I started. Instantaneous is where am I relative to where I just was.
So both of these include displacement?
Both of them, so I can have instantaneous displacement or overall displacement.
Mm.
The default is overall. If I just say what is the displacement, this is what I'm asking.
Mm.
If I want instantaneous displacement, then I have to specifically say instantaneous. So that's why when I'm doing the plus minus zero exercise, I'm asking for overall displacement. I'm not asking where I was, a microsecond before. I'm asking where am I relative to overall, from where I started. Velocity, there's instantaneous, and there's average. If I want average velocity, I need to specify average. Instantaneous is the default. So if I just say what's the velocity, I'm asking for instantaneous. Back to the speeding ticket analogy. If the policeman has a radar gun and zaps you with the radar gun, he's measuring your instantaneous speed, actually. But if you've ever gone through, especially I've seen in rural areas, speed check by aircraft. So basically you have some plane overhead, they're not hitting you with a radar gun, they've got landmarks, and they're measured, and they know how far apart they are, and they're just timing how long it takes for you to get from one landmark to the next landmark, doing just that distance divided by the time to figure out what your average speed was. Average speed, you're looking at 2 moments in time. Instantaneous, well, it's still 2 moments in time, but those 2 moments in time officially are so incredibly close to each other, it's very difficult to tell them apart. All right, so let's go to questions before we do plus minus zero with the three big ones right here. All right. Zero is still here. My starting point is still there. If it makes you feel better, I'll start here. So position displacement is still the same as before. Velocity cares about the direction you're going. So it's positive velocity if I'm going that way, it's negative velocity if I'm going that way. All right, so my position.
Zero. Negative zero?
Negative zero.
I don't know.
All right, so it's relative to zero. Am I on the left side or the right side of zero?
Well,
Left side.
Yeah, did somebody say right? This is the left over here. Yeah. And because I said to the right was positive, I'm on the negative side.
Uh-huh.
All right.
So displacement, I would just put negative.
Displacement is indeed negative because I'm on the left side of my starting point.
Uh-huh.
All right. So we'll work our way through that again. All right, so my position,
Negative.
displacement,
Negative.
velocity,
Negative.
my velocity,
Positive.
displacement,
Negative.
position, Alright, one more round position, displacement,
Positive.
velocity,
Negative.
alright, we're on a roll. Do a quick little map review here. If I go from 5 meters per second to 15 meters per second, so this is my initial velocity and my final velocity. Again, using the subscript I for the start, initial, and F for final. What is my change in velocity?
Ten.
10 meters per second.
There we go. How'd you get 10?
Subtracting 15 and 5.
The order matters. So it's final minus the initial. Change always final minus initial. So the V final minus V initial. 15 minus 5. Suppose I go from initial velocity of 5 meters per second to 0 meters per second. That's my final velocity. What's my change in velocity now?
Negative 5 meters per second.
Okay. And I go from negative 10 meters per second to negative 5 meters per second. What's my change in velocity now?
5 meters per second.
Now, if you're unsure, and I get a wide variety of math abilities in 110. It's always the final value minus the initial value. You can do it on a calculator if you're feeling really shaky about it. And the double negative is a positive, so it's negative 5 plus 10 or 5. That's the math. So now, acceleration. The symbol for acceleration, they went all out for this one. A, lowercase a, with a vector symbol over it. This was speed. The scalar analog of acceleration is, unfortunately, acceleration. Now, the fact that that is a capital A for acceleration, and this is a lowercase a, is completely meaningless. It's just the fact that's just the way I wrote it. The symbol for acceleration, the scalar acceleration, is A without the vector symbol.
Lowercase?
Yeah, the symbol is indeed lowercase. If uppercase, lowercase did not matter in terms of symbols, we would run out incredibly quickly. Uppercase, lowercase, I think I talked about this one. I know it did with one of the classes. I think there are 100 symbols. Greek and Roman alphabets, uppercase, lowercase. Now, on a test or quiz, if you were asked what is the acceleration, which one is it? On quizzes and tests, and I've gotten better about this and I've corrected some old things, I should have the A with a vector or A without the vector right after the word acceleration so you know which one I'm talking about. If I don't and you're not sure, can't pick it up from context, then ask. Typically in a textbook, when they ask for acceleration, they are talking about the vector. They don't distinguish between the two when they just say, what is the acceleration? This is the one that typically, 99% of the time, is the one they're talking about. acceleration is the time rate of change of velocity, which is just a fancy way of saying that the average acceleration is the change in velocity over the change in time.
Wait, say that one more time, the last part?
So average acceleration is just the change in velocity divided by change in time.
Okay.
At what rate is the velocity changing? It is also, there's another mathematical relationship. It is the total force divided by the mass. So acceleration is also force, total force divided by mass. Now that second equation down there, we've at least talked about forces, and that's one of the reasons Hewitt puts forces first, is so that we can talk about forces now. But that equation officially is Newton's second law, which is chapter 4. But the key point I want you to pull out of chapter 3 here is that the acceleration and the total force are in the same direction. Those are the only two vectors in this equation. So my acceleration and my total force are in the same direction. They have to be. All right, so assuming all of you can drive, or at least can imagine what driving looks like. When you are driving, you have access. You as a driver have easy access to 3 accelerators. What are the 3 accelerators in a car?
The gas pedal,
That's 1.
the brake.
That's 2.
Your,
Gear?
yeah.